Okay, so hi everybody, good afternoon and welcome to the session on designing and analyzing weld sizes with SolidWorks simulation. Okay, so let's start. Yeah, I think I'm loud and clear. Okay, let's start. So in today's webinar, we are going to see how we are going to design and analyze weld sizes with SolidWorks simulation. Okay, myself, I am Rajesh Celestine. I work as an application engineer for Atmata. Okay, so today's agenda. So in today's agenda, what we are going to see here is, first we are going to understand some basic welding terminologies. Then we are going to see some weld analysis, how I'm going to apply weld analysis on a sample weldment assembly. And then we will study how to understand the results, the weld results. And then we have, I have designed some assemblies where we will create some weld analysis on these assemblies and see how we study them. Okay, so we will see some basic terminologies what we are going to use in SolidWorks for weldments. So we have the fillet weld and we have the groove. So here we have the fillet weld, which is single-sided and double-sided, as well as we have the groove weld, which is a single-sided weld and a double-sided weld. So considering this fillet weld, where I have two components, two plates, and you can see here I have the weld throat, which starts at the root to the face of the weld. So this depth is called the weld throat, and then I have the weld size, which starts at the root to the toe. So from the root to the toes, this is called the leg of the weld. So if you have it on one side, it's called a single-sided weld. If you have the weld on both sides, it's called a double-sided weld, and this is called a fillet weld. The similar way we have it with the groove weld. So the groove weld is nothing but the groove is actually prepared on edge preparation. So when we create welding, design welding parts, what we do is we have edge preparation. So based on our edge preparation, the depth of the weld size is being calculated. So the weld size, you can see here, this is the weld size based on the edge preparation, and you have the weld throat from the root to the face. Okay, so these are some of the basic terminologies what we have with welding. Okay, this is just a tip for you. So we have a welding part. So like for example, you see a solid and you see a surface body on top. So always when you do when you create weldments, you can do it with surface bodies or with sheet metal bodies. Okay, the terminated part always has to be a shell. So you can have here two shell features and one shell feature and one solid feature. Okay, like most of you are beginners, you might have a confusion or you might have a question, what is a shell feature and what is a solid feature? I would like to explain this offline. I will explain this to you offline. What is a shell feature and what is a solid feature? So this is a tip for you where you have to remember, keep this in mind when you design your weld. Okay, so here I have a very simple part. I am just going to demonstrate how I use welding on this. So if being a designer, I'm going to design this tube. I have a design of these tubes. I have a longer tube, I have a bend, I have a shorter tube, I have two support plates at the end, as well as I have a support at the bottom. Okay, so let me demonstrate this and show you how we apply weld on this. So like you see here, I have a sub-assembly. So this is my sub-assembly. And then I have a shorter tube. I have a plate at the end, and then I have a bend. Okay, so as usual, we start with SolidWorks. You have your SolidWorks add-in, and this is available only with premium. So simulation is available only with premium, not with standard and professional versions of SolidWorks. Okay, so here I start with a new study. So let me start with a new study. And in this case, I'm going to do a static study. So this is a linear static study. Let me give the name of the study. So I'm going to say this is going to be a weld analysis. And say, okay, so I started a new study here. Sorry, okay, I already have one. Let me create another name. Okay, so I started with a new study here. So what we see here is I've got into the simulation study here. I have all my parts here listed in the simulation study. So you can see some of the icons here which represents a shell and some of the icons here which represents a solid. Okay, so The first thing here, what I'm going to do is I'm going to give the thickness to the shell. So I select my shells. So as you can see here, I can select the tubes. And the tubes, I need these tubes to be around 3 mm thick. So just right click this, and I'm going to say that this is going to be 3 mm thick. So I give a thickness for this. So this has been converted as, this has been taken from a surface. So the SolidWorks simulation study recognizes this as a shell. So I'm applying a 3 mm thickness to this. And then I have the top and the bottom face. So you can see here, as you can see here, this represents the bottom face of the shell based on the color coding, and one side represents the top. So I can flip it. So I want this to be the top. And here I have the option where I can give the offset. So how my thickness should be offset, towards the inside or towards the outside, or in between, the mean. Okay. So you can see here, as I keep flipping this, my thickness changes. So in this case, okay, I'm going to say it should be offset towards the inside. I'm going to click OK. So a surface has been assigned, or it has been created as a shell with editing the definition and adding the thickness to it. Okay, let me add the thickness to this part. So I right click this. I will say edit shell definition. In this case, I need this plate to be around 5 mm thick. So you can see here, this is a shell body, surface body, and you can see the shell which has been created, and the offset is in between. So it is 50-50. So in this case, what I'm going to do here is, I am not worried about the top and the bottom, whereas I am worried about the distance from the support plate to the inside of the other support plate in the bottom. So I give my offset towards the left side. And let me say OK here. Okay, so having done this, now what I can do is, let me apply the material to the part. So in this case, I'm considering all this as a plain carbon steel. Okay, having applied my material, so usually by default, SolidWorks creates a global contact which is bonded. So the component connections between each other are going to be bonded. In this case, what I'm going to do is I'm going to delete this bonded connection, and let me add some welded connections here. So I have the edge weld here. So let me select my edge weld. Now, let me say I'm going to start with a fillet, which is a single-sided fillet. Okay, so this is what you get when you add a weld connection. This is your interface. Okay, let me pin this interface because I'm going to add number of welds. Okay, so in the first case, I'm going to select the face of set 1. So in this case, what I need is, I need to first select, always remember this, first select the terminated face. So this face is actually terminating here. So I select this as the first face. Okay, so this is going to be a single-sided weld, fillet weld with this plate and this edge. So having done this, you can see my mouse cursor on the right side. I have a green arrow. So where I can say, I can just right click. So when I right click, it moves to the next option. So here I'm going to select the face of the plate, and then again a right click. So this gives me a fast control over my commands. And then select your edge. So once I select my edge, it defines the first face, the terminated face, the second face, and the edge. So always remember, you have to start with the terminated face. Okay, now we have two arrows pointing out. So one arrow which is pointing towards the top, and one arrow which is pointing towards the right side or the outside. Okay, so the arrow pointing towards the outside is the side of the weld. So I can flip the side of the weld as required. Let me select it again because yes, okay, because when I flip it, I'm having some issues with my graphics. This one. Okay, so let me have this outside. Okay, so I'm going to weld on the outside, and the weld is going to start from this yellow sphere in this direction, the anti-clockwise direction. Okay, now here what I have is, I have two standards here. So I have the American standard, I have the European standard. So in my case, what I'm going to do is, so I'm going to select the American standard. So selecting the American standard gives me an option to choose what kind of electrode I'm going to apply here. So in my case, I am selecting the E80 electrode from the American standard. And here you have your weld strength for this electrode. And you can change the units if as required. Whereas if I go to the European standards, you can see also I have an option here where I can also add custom parameters here. So what is my ultimate tensile strength of my electrode can be added here. Okay, let me go with American standard. So I have my E80 electrode assigned. And here we have two options here. So we have the factor of safety versus safety factor. So as I hover my cursor on this American National Standards for Automotive Lift, you can see it shows me a standard. This is in compliance with B153.1.9. So this is in compliance with this. And you see there is a standard factor of safety which is around 3. I have another standard factor of safety which is coming under the lifting devices, so hook for lifting devices, so from this institute. So this is showing me a factor of safety of 5. So as I place my cursor here, you can see it is nothing but it is the ANSI or ASME B30.2. So you have two options where you can choose your factor of safety. Also, you have an option where you can add the type of factor of safety you require. So having selected American National Standards for Automotive Lifts, this factor of safety, let me just give a estimated weld size of around 3 m. Okay, so I do not know how much I'm going to apply a weld here, but I'm just going with a sample with just a measurement of 3. So once I've done this, I'm going to say okay. So one weld has been applied. Now in this case, now in the next case, what I'm going to do is I'm going to use a fillet double-sided weld. So you can see here, I have the terminated face. Select your terminated face, right click, select your pipe, and you see it selected the intersection of the surface and the pipe. Okay, so the same standards are in place. Then I'm good to go. And let me say okay. So let me move to the next one. So in this case, I'm going to have a groove weld, which is a single-sided. So I select groove weld. And let me select my faces and my edge, having the same size of 3 and electrode of E80. Let me say okay. So let me complete this by adding some more welds, and this is also going to be a single-sided groove weld with the same parameters, and it's done. Now here, let me select the fillet, which is a single-sided fillet. Always remember to select the terminated face first, then and then the intersection edge. So what we saw here was I applied a fillet weld of 3 mm, size 3 mm. Okay. Now I'm going to run this study. So I have all my welding connectors here. And now what I'm going to do is I'm just going to run this study. So SolidWorks will do the meshing. It will create the mathematical model. And based on that, it will give me the this one. Okay. So what I was missing out here was I was missing out some connections. Sorry for that. So let me add some connections. Okay, where I'm going to fix this. So one side I'm going to fix my plate. So let me fix my plate on the longer side of the tube. Okay, right. And then let me add some external load. So the first thing is I'm going to add the gravity here. And it's going to take the self load of the assembly. And then let me add a force at this area. So on this top face, let me add a force of around 3000 newtons. Done. Yes, I'm good to go. I think I have not left out anything. Right. Okay. So let me run this study now. So SolidWorks will solve for it will create the mesh. So the meshes are calculated on the default values. Okay, so once it creates my mathematical model, it will produce my result. So now I've got my stress results here. So I've got my 1 stress. Okay, I did a mistake here. So I need to have this as 3000 newtons. So let me increase another 0 and run the study. So we have the weld plot study here. So we can study the weld here very quickly. So what I did in this was I applied a 3 mm on random. I just selected 3 mm thickness of weld. And when I right click the results, you can see here I have the option where I can define a plot for the weld. So this will give this is called a weld check plot. So let me select the weld check plot. So in this case, you can include a text here. So you can include a text analysis. So whichever view you want, you can select that particular view. So I'm selecting the top view, and you can see here I have my weld results. So these weld results. So what we see with these weld results is, so I see some on the screen. I see some of the welds which are green, marked in green. I see one weld which is in red. So it shows me here there is a weld which needs attention. So when I click on this, you can see here as I applied a 3 mm of random weld size, it says that the weld size here, which has been calculated on these forces, based on these forces and movements, are around 8 mm. So you require a weld of around 8 mm. Okay, let us do a study into this welding. Okay, so this weld is a failure, or it needs attention, so it's going to fail for this particular load and boundary constraint. Let me see the other welds. So when I go to the other welds, you can see here I have a weld. So it says here the calculated weld size is 0.25. Estimated weld size is around 0.3. So yes, I have done some excessive load here. So I can reduce the weld size here. This saves me time and cost. Okay. So let me go to the next weld, and I see here the weld size is around, the calculated weld size is around 2.43. Whereas I have given a weld of 3. This is okay, right? So we see here 4 welds are okay. One weld needs some attention. Okay, let me do a bit of study on the welding. So when I go to the details here, you can see here, it shows me different, different forces which are acting on this weld. So as this is a torque, giving a torque kind of motion to this weld, you can see the defined weld throat. So the weld throat, the minimum size of the weld throat is 0.79. The maximum size is 6.2. The mean is around 4.3. Okay. So I have some forces also which are displayed here. So let me explain these forces to you. So as we see here, this is what I have. So we see the joint normal force on the weld. So which is TJ. So TJ is nothing but it's acting perpendicular to the weld seam, and then we have the shear force on the weld axis. So this is nothing but TW, which is acting parallel to the weld seam, and then we have the shear force, shear normal force, which is TS, and then also we have the bending moment. So based on all these forces which are acting on this weld has been calculated. Okay, so let me come to SolidWorks, and here I have some report options which are available here. So I can select the plot. Now this gives me an insight into my weld. So what this shows me on the graph, the x-axis on the graph shows me the perimeter of the area it has been welded. So this is the perimeter. So this is the length of the weld. So along the distance or the travel along the length. So from this yellow sphere starting here, as this is moving anti-clockwise, you can see that it requires a higher weld or a thickness of more weld at this particular point. So 42.74 mm, somewhere at that distance, it needs to be having a weld thickness of around 8.69. Whereas you see the similar thing applies on the opposite side. So around a distance of around 117 or 118 mm, there should be a weld of at least a minimum thickness of around 8.5 or 8.6. So this gives us an insight into where the forces are acting, how the weld should be calculated, and how you could design your component using this analysis, the forces which are coming onto your weld. Okay, and you can see here on screen I have a very clear visualization of which are the welds which are passed and which are the welds need attention. Okay, so this is a simple example what I showed you here, and what I explained to you are some of the forces here. Okay, so what we see here is I have actually a bracket. So now there is a bracket or a C channel where I have a gusset, where I have two gussets and a base plate with a boss. And I'm going to apply some load on this. And let us see in a practical situation how we will analyze this loading. Okay. So let me go to SolidWorks. Let me close this. And let me start with my bracket assembly. So like you see here, this is a simple case. This is a case which is something which is a welded structure. Okay. So what I have here is I have a long tube. So this is a beam, and then I have a base plate. I have two gussets in the side. So I have a boss here. So on this boss, there is something going to be mounted on this. So there is a machinery which is going to be mounted on this. So I need to calculate the load which is going to come on this welding of the gusset. And I need to know if this weld will withstand that particular load. So in this case, let me show you how I'm going to take the approach with SolidWorks. So let me start with a new study. So here is going to be static. You can name your study. And then, okay, the first thing what I'm going to do here is I'm going to assign my material. So I'm just going to take plain carbon steel for all. And then here you can see I have a shell. So this was created from a sheet metal part. So what we saw here, this is from a sheet metal part. I think the gusset is from a sheet metal part. Okay. And one is from a solid body. So I think this boss is from a solid body. So we can see this from a solid. So sheet metal parts are usually converted into shells. As soon as you switch on to simulation, they are converted into shell. Okay, let me check this longitude. So this longitude, when I say edit definition, since it's a shell feature, you can see automatically I no need to assign the thickness here. Automatically, SolidWorks simulation has assigned the thickness and created the shell formula. So there is nothing I have to create. Okay, so when I go for the gusset, let me say edit definition. You can see with the gusset, the similar thing happens here. So this is a shell, sheet metal part of 3 mm thickness. And yes, because it's a sheet metal component, so simulation has actually calculated all the values for me for the shell. So I have some shell components here. So I don't need to work on any of these shell components here. Now, having my component interaction, which is called the component connections as globally bonded, let me add my fixtures and let me run the simulation first. So first I need to analyze where is the load coming or where is the critical stress coming on this part. Okay, so what I'm going to do here is I'm going to apply some fixtures. So I'll apply the fixture geometry. So let me select these edges and say that this part is going to be fixed. So in this case, I'm not going to apply any welding connections now. So this is the first initial study considering everything as bonded. Okay, so having done this, now let me apply a force on the boss. So I select my boss and I say I'm going to apply a force of around 5,000 newtons in the normal direction to the face. And let me say okay. Now let me run this study. So this study will give me an insight into where the excessive stress is being applied on the part. Based on the bonded connection, assuming everything has been bonded, I will get the approximations of the stress. So you can see here, okay, I'm afraid to run the animation. So you can see here it behaves as applied. So as the boundary condition, both sides fixed and the force applied, the behavior is right. Okay. One thing I notice here is, like this part is trying to tear off. And since I'm going to apply the load with in between the longitude and the gusset, I think this will also be critical for the welding also. Okay. So now let me apply my weld to this part. So now let me go to connections here. And let me say I'm going to apply a weld connection. So remember here there is a bonded a bonded component connection which is already applied globally. So as and when I apply my welded connection, this will override the bonded connection. Okay. So let me say I'm going to use a single-sided weld in this case. Now let me remember to select the terminated part first. Give an enter. Select the longitudinal face, and now I will select the intersecting edge. Okay. So let me pin this because I'm going to apply it for the other side of the weld also. So let me go to American Standards. Let me select the same E80. Yes, it's done. Okay. And okay, let me say MPa, Newton per mm square. Then when I move down, I have here my estimated load value. So I'm going to go with this American National Standard for automotive lifts. And here I'm just going to apply my load. So I'm going to, let me take an approximation of 3M, for example. Okay. So I just start with 3. And let me say, okay. So the similar weld, I'm going to apply it on the other side. So start with selecting your terminated face, give a right click, select the longitudinal face, right click, and then the intersecting edge. And let me go with the same parameters, and let me say okay. So having created my weld here, so this overrides the bonded connection. So let me run this study now. So after completing this study, what I'm going to do is I'm going to run a weld plot check. So this weld plot check is going to give me an insight into the welding. Okay. So as usual, right click your results, define weld check plot. So you can use your image here if as required. So in this case, I'm not going to use the particular view or image. And you can see here, it tells me that these welds need attention. So both the welds have failed in this case. So I have here a weld size, because I gave an approximation of 3. I have no idea of how much weld to be applied. I just gave an approximation of 3. So it tells me it needs at least 5.39. Okay, let me check the weld on the other side. So this weld is around 5.43. So approximately very close to each other. Okay, let me do a small design check. So since I've applied this weld on one side, let me do one small modification in the weld. Okay, so let me come to this weld. Edit definition. Okay, what if I give a weld which is double-sided weld, and I'm going to select the same edge, and I'm going to say that this weld is going to remain 3 on it, but I'm going to apply 3 mm weld on either sides. So let's see what happens. So this is a small design game what I'm going to play here, and I'm going to run the study. So I'm not going to increase the weld size on one side. I'm just trying to do a design study where I could give the same size of weld on either sides of the gusset. Okay, now let me check the weld problem. Yeah, good. So you can see here, this weld has passed. So just doing a simple design study, what I see here is, if I'm applying a weld on both sides of the gusset, I need to have a minimum size of around 2.37 or 2.4. Whereas I've given 3 and this weld has been passed, right? So this is just to give you an insight. So if you go and study the weld on the other side, like I told you, you can just click and you have the option here where you could get into details of this weld. Okay, you can see the forces acting here. And as I keep moving here, you can see since the weld starts from the top to the bottom, you can see here the weld, when I do the weld study, you can see here the weld thickness is required more on the top. So you can see from here it starts more, and as it keeps going down the length, it reduces. Okay, because the tearing force here or the bending force here is more on the weld. So this results also can be studied. Also can be saved into a notepad file, and also you can put it into you can copy it to your clipboard. Right. So this is just to give an insight of weld studies. I actually designed another lifting bracket here or lifting arm. So it was fun doing this designs. So you can see here I have a lifting arm assembly. So I wanted to do a study on this. So these are all sheet metal components here, and this is going to be lifted with a hook, these points. And what I'm going to do here is I'm going to apply a load here, so which is going to be towards the gravity, and I've done a study on this, and you can see, here I have a weld check plot where I can study the weld strength on these hooks. So a very quick way to assess your welds. Right. Okay. I think I've completed most of this presentation. I believe this webinar would have given you an insight into SolidWorks Weldment. You can also connect with our technical team. We will also help you out. You can also connect with us on LinkedIn, Facebook, Instagram, Twitter, and we have regular webinars which we are webcasting every month. So, if you have any questions, I would wait for you. If you have any questions, you could raise your hands, and or you could also raise your hand, or you could send it in the chat box to me. Let me wait for some time. If you have any questions, yes, you can raise your questions to me. Or we are also available in mail, in our regular support mail. You can send your feedbacks. We will really be glad to help you. Any questions, please? Okay, I don't see any questions. So thank you all so much for attending this session, this webinar. I hope this has given you insight into welding, and I hope this will benefit you. Thank you so much, and have a nice day. Bye-bye.